This is a video key for the second comprehensive review packet for my algebra class. So we're going to start by solving some one-variable inequalities using the boundary point test method. First thing we're going to do is we're going to take this inequality and we're going to rewrite it as an equation. So we're going to write this as 4x plus 2 equals negative 6. Solving this using our regular algebraic solving strategies, we get that x is equal to negative 2. And what this tells us is that the two sides of this inequality are exactly the same at negative 2. I'm going to put an open dot there just because we see that there's no equals in this equation. So we don't want to actually include negative 2 in our solution. Now what we're going to do is we're going to test values on both sides to see whether the solution is to the left or to the right of that equality point. So I'll plug in x equals negative 3 into my inequality. Remember, we're back at the inequality now. 4 times negative 3 plus 2 is greater than negative 6. Simplifying that, I get negative 10 is greater than negative 6, and since negative 10 is to the left of negative 6 on a number line, we know that this is a false statement. So we now expect the solution to be to the right, but we're going to test a point to the right anyway. I'm going to choose x equals 0. 4 times 0 plus 2 is greater than negative 6. Again, this isn't a true or false statement. Or excuse me, it is a true or false statement. We do not want this to be equals. So we get that 2 is greater than negative 6. This is a true statement, which means that my solution goes to the right. And that means that my inequality is all my x values in this solution must be greater than negative 2. All right, switching to the next page, we have some more practice problems here. And what I will do is I will go through the next one quickly and then just write the solutions for the rest. So we've got 5x minus 2 equals negative 12. Solving this, add 2. 5x equals negative 10. Divide by 5. And we get x equals negative 2 again. But this time notice that there's an equals, which means I'm going to put a solid dot. I'm going to fill in that dot to show that that's part of the solution. We will test x equals negative 3. We plug it in to the inequality, not the equation this time, because we already know it wouldn't be true if we plugged it into an equation. It's only true, the equation's only true at negative 2. And we get negative 17 is less than or equal to negative 12, which is in fact a true statement. We'll test a point to the right. We now expect our solution to be to the left, but I like to test on both sides anyway. And we get negative 2 is less than or equal to negative 12, and of course that is a false statement. That means that my solution is to the left, and my inequality is x is less than or equal to negative 2. All right, so there's the process. I've done 2 examples. What I get with the boundary point, and I'm not going to walk through the math on each of these, is I get a boundary point at negative 1. If I test x equals negative 2, I get false. And you can test any point you want as long as it's below negative 1. And when I test x equals 0, I get true, which means that my solution must be to the right of this boundary point, and my inequality is x is greater than negative 1. We've got 2 more. So again, I'll just give you what the results are so you can check your work. We get that x is approximately negative 4.5. This one worked out to be sort of an ugly decimal, but I suspect a typo. In the meantime, we'll leave it alone. We'll put our solid dot right here at approximately negative 4.5. I tested x equals negative 5 and discovered that the inequality was true. I tested x equals 0, discovered that the inequality was false, which means that my solution is to the left, and my inequality is x is less than or equal to negative 4.5. We don't have a way to really signify approximately on this one, so we just leave it as less or equal to negative 4.5. Final problem, solving for the boundary point. I discover that x, whoops, don't know why I wrote that, x equals negative 4. So annoyingly, these are all negative. Gosh, wouldn't it have been nice to have just one positive? But it's okay. I tested x equals negative 5, and I discovered that the inequality was true. I tested x equals 0, discovered that the inequality was false, and therefore my inequality goes to the left, and x is less than or equal to negative 4. All right. So that is solving inequalities using the boundary point strategy. We're going to switch to doing some function notation. I'm writing these times up in the corner because I'm going to put timestamps in the description for you. Be a little careful on this one. Notice that we've got lowercase and uppercase. There's 6 functions, but 2 of them have f, 2 of them have h, 2 of them have g. Lowercase f and uppercase f are 2 completely different things in math, so you want to watch out for that. But what we do know is that this is our input value. This is our x value, regardless of what the equation is. So what am I going to do with that too? I'm going to plug it in 2048 times 1/4 squared. Be careful to put the 1/4 in parentheses. If you do not put it in parentheses, if you type into your calculator that, you're only squaring the 1. You have to have those parentheses. So your solution here is 128, and I'll work through a few more. F of negative 3, there's your input. Notice uppercase f, so this is negative 4 times negative 3 plus 11, and that equals 23. Lowercase g of 4, 2 times 4 squared plus 5 times 4 minus 10. Notice that I'm putting these numbers in parentheses. There's no parentheses in the equation. Doesn't matter for a positive number, but it matters for fractions and it matters for negatives. So I would just get into the habit of writing these inside parentheses. And when we evaluate this, we get 42. Lowercase h, that's 2 times 4 to the power of negative 5. And this is going to give us a decimal, and it's approximately 0.00195, and we should write this as an approximately instead of an equals. Uppercase g of 0, uppercase g, of course, is this function, negative 2 times 0 plus 6, and 0 plus 1. This may look familiar from your quadratic workings. And we get that this is equal to 6. F of 20, lowercase f of 20, 13 times 20 minus 9, gives us 251. Uppercase h of 17, uppercase h, 2048 times 1/4 to the 17. Again, watch out for those parentheses, or you will get a wrong answer here. And this is an interesting one because your calculator may give you something that looks like this. Well, -7 means move the decimal 7 points to the left, and our actual answer looks something like that. F of -8, lowercase, 13 times -8 minus 9 is -113. Uppercase g of 1/2, -2 times 1/2 plus 6, 1/2 plus 1, and we get 7.5 when we type that into our calculators. Uppercase f of 1.5, -4 times 1.5 plus 11 gives us what does that give us? Negative 6 plus 11. I don't know why I didn't have that one written down on my little cheat sheet over here. Lowercase g of negative 21. Now, this is where these parentheses come in so importantly. Just a reminder that if you type negative 21 squared into your calculator, it will give you a negative number because it will do the exponent and then multiply by negative 1. Obviously, a negative squared is a negative times a negative, which is a positive. And so this is not the right way to plug that into your calculator. You will get positive 767. And finally, lowercase h of 0, 2 times 4 to the 0, and anything to the 0 is 1, so this is just equal to 2. Okay, that was a quick review of function notation. Remember, this is the input, the x value on the function. This is the name of the function, and all you're doing is evaluating the function at that point x equals 2. Okay, let's move to domain and range. So, domain, remember, is all x values. Range is all y values. So, my domain on this shape right here is from negative 5 to positive 5. It includes both those values because it touches the edges. So, I get negative 5 less or equal to x less or equal to positive 5. And my range goes from negative 2 to positive 6. Remember, we always do minimum less than maximum, and this is x or y. And it could have an equals there depending on whether it touches or it doesn't, but it's always from minimum to maximum, so the range is negative 2 less or equal to y less or equal to positive 6. I wrote a negative right there, don't know why. All right, let's move to the right. My domain starts right here with that solid dot, and it continues all the way to here with a solid dot. That is negative 7 to positive 7. So again, negative 7 less or equal to x less or equal to positive 7. Now, the range, a little trickier because we don't care about the dots. We only care about the lowest value. This starts here at negative 2, and it goes all the way up to here at positive 6. So my range is going to be negative 2 less or equal to y less or equal to positive 6. Okay, jumping down to this fourth one. Notice that we have an arrow. This goes forever to the left, and it goes forever up. So my domain goes all the way from negative infinity to positive 6. Negative infinity, less than x, less than or equal to positive 6. Notice you can't be equal to infinity, so no equal signs on that. And my range starts at negative 4 and goes up forever. We don't care about that dot because it goes below the dot over here before it comes back up again. So my range is negative 4 less than or equal to y less than positive infinity. Finally, we've got some open dots, so this is a little bit different here. This starts at negative 6, and it goes all the way to positive 6, but it doesn't include those endpoints. So we've got negative 6 less than x less than positive 6. Notice no equal signs. And my range starts here at negative 6, but notice that it touches right there. And it goes up to negative 2, but does not include negative 2. So I've got negative 6 less than or equal to y less than negative 2. Okay, we are turning the page, and we are done with oh, wait. I take it back. There are some more domains and ranges, so I'm just going to go ahead and draw them. I'll spend a little less time on these unless I see something odd. Negative 6 less or equal to x less or equal to 4. Range starts here, goes all the way up to that maximum there. So I've got negative 7 less or equal to y less or equal to positive 6. Coming down here, my domain from here all the way to there, -5 lesser equal to x lesser equal to 1, and range, there's my minimum value, there's my maximum value. So I've got -1 lesser equal to y lesser equal to 5. Notice this isn't a function, but it doesn't matter because it still has domain and range just like a function. From here, my domain, notice, does not include that left point. So I've got -2 less than x lesser equal to +2 because it does include +2. My range goes from -2 to +2 but does not include either of those numbers since they are open circles. And finally, I have from -4 to +1, not including -4, but yes including +1, and I've got from -2 to +1, not including -2, but yes including +1. All right, that is now the end of my domain and range discussion. So let's write some linear equations. So we've got two kinds of equations here. Notice this is one of these pricings. We've got adult tickets for $8, student tickets for $5, a total. So we've got a price, and a total. These kinds of equations are always price times quantity plus price times quantity is equal to total. So this is price times quantity, that's for adults, plus price times quantity, that's for students, equals total. So let's do these three. We see 12 times the pounds of almonds that we purchased, plus 9 times the pounds of cashew we purchased, which works out to $108 worth of mixed nuts. And we see $45 times the number of scientific calculators plus 120 times the number of graphing calculators equals the total amount spent on calculators of $1,800. Now, over here, this was our ax plus by equals c, our standard form equations. These ones are starting point growth rate. We're starting at 25. We're adding 10 cents per message. Y equals 0.10x plus starting value of 25. We're starting at 500. We're adding 12 gallons per hour. Y equals 12x plus starting value of 500. It is draining, which means it is -12. So that's ugly. I will write it again as -12x plus 500. So be careful. Draining means going down. We want to catch that before we write the wrong equation. And finally, starting value, growth. We've got y equals 3x plus 15. Okay, turning to the last page, there's absolutely nothing to do here, except maybe draw yourself a picture if you got nothing else going on. And so, thank you for watching my video, and I hope this helped.